Hello everyone. In this video, we will be solving some important questions from Neet, JEE and JAM examinations. And at the end of this particular video, the topics which will be covered will be van der Waals constant, atomic radii of group 13 elements, acidic character of oxides of group 2, ionic character of hydrides of group 2, structure of ClF3 and calculation of oxidation state. So let us try to see the first question. Given van der Waals constant for NH3, H2O2 and CO2 are respectively 4.17, 0.244, 1.36 and 3.59, which one of the following gas is most easily liquefied? And the options are this. Now, very important for this particular or this type of question to tackle or to answer is to understand what is van der Waals constant and what is the significance of van der Waals constant. Very important. Now, the van der Waals constant, you can find it out in van der Waals equation. The van der Waals equation for n moles of a gas is P plus n square A by V square, V minus NB equals to nRT. In this equation, what you can see as constant A and B, small letter A and B, are nothing but van der Waals constant. Now the question is, what is the importance of this van der Waals constant? So let us try to see first for the constant A. It is the indirect measure of magnitude of attractive forces between the molecules. Greater the value of A, very important, more easily the gas can be liquefied. There is our answer. So the value of A decides how easily the gas can be liquefied. So how it decides? If the value of A will be more, the gas will be easily liquefied. Thus, easily liquefiable gas, so those gases which are easily liquefiable like sulfur dioxide, NH3, H2S, CO2 have high values than the permanent gases. Permanent gases, those gases which are not very much easy to liquefy like N2, O2, H2, He. These gases are very difficult to liquefy. So these gases always have a lower value of A. Okay, and if we go for the constant B, what it suggests is also called co-volume or excluded volume. Its value gives us an idea about effective size of the gas molecule. Greater is the value of B, larger the size and smaller is the compressible volume. Okay. As B is the effective volume of the gas, the constant value of B for any gas over a wide range of temperature and pressure indicates that the gas molecules are incompressible. So for this particular question, our answer is by taking into consideration the constant A. So if we try to see the values which were given in the question, then what you can see is the correct answer for this particular question is ammonia, which has the highest value of A as given in the question. Okay, so our answer is ammonia, NH3, for this particular question. Let us move into the next. The correct factor A to the ideal, the correction factor, sorry, A to the ideal gas equation correspond to, as we have discussed just now, electric field present between the gas molecule, volume of the gas molecule, density of the gas molecule, forces of attraction between the gas molecule. So our correct answer is forces of attraction between the gas molecule. That is what we have discussed just now. So it is the same, actually, the question from the same topic. Let us move into the next. The correct order of atomic radii in group 13 element is this. Now, some of them may take it as a very easy question, and from their general idea of about atomic radii, what do we know is that when we move in any group, then the atomic radii always increases. Is it not? That is a very common trend, or that is what we have learned also, and that is definitely true, but not in all the group, and especially not in group 13. That is why most of, actually this type of questions are given, where most of the students tend to go for actually the option where they find out that it is decreasing the increasing down the group, which you can clearly see, okay, in certain options. Now what we need to understand over here, or how the variation happens, there is an exception in group 13. The atomic radius of gallium is slightly lesser than that of aluminium. So remember that we have boron, aluminium, gallium. Gallium is below aluminium. So gallium must be bigger in size compared to aluminium. But if you compare gallium and aluminium, gallium is lesser in size than compared to aluminium, which should not be. Now, why it is happening? Because in going from aluminium to gallium, the electrons have already occupied 3D subshell in gallium. Remember that we first fill 3D, then we come for gallium. Okay. The screening effect of intervening electron, the inner electron, okay, being poor. Remember that the shielding effect of 3D electron is very less. I hope most of you can understand shielding effect. It is nothing but, in very simple word, if I try to keep it in very simple word, it is nothing but the repulsive effect. The inner electron always have a tendency to repel the outer electron. The more is the repulsive force, the more is the shielding effect. The less is the repulsive force, the less is the shielding effect. And d electron repel the outer electron less. That's why we say that the shielding effect is poor. Okay, that is how, in very simple word, I can explain what is shielding effect. Okay, being poor and has less influence to decrease the effective nuclear charge. Obviously, when the repulsive effect will be less, when d electron will not push the outer electron outwards, so what will happen? Obviously the effective nuclear charge will not decrease. Okay, so we'll have less influence to decrease the effective nuclear charge. The effective nuclear charge will increase. Therefore electrons in gallium experience more force of attraction. See, when the screening effect is less, when the repulsive effect is less, then the attractive force will be more, as a result of which it results in the lower size of gallium than aluminium. Okay, so please remember this is very important. So if you try to see, that is our answer. So barium will be less than gallium, gallium will be less than aluminium, and aluminium will be less than indium, and finally indium will be less than thallium. So that will be the correct order. Let us move into the next. Which of the following oxide is the most acidic in nature? And the options are given. And if you clearly see, the options are of group 2 elements. All are group 2 elements: barium, beryllium, magnesium, calcium oxides. Okay, so the oxides of group 2. And they have asked about acidic character. Now, a very simple logic, okay, whenever you try to answer the acidic nature or basic nature of oxide, always remember that whenever we talk about oxides of metal, then they will always be basic, and oxides of non-metal will always be acidic. Okay, so whenever you are moving in a periodic table, if the metallic character increases, then the basic character increases or the acidic character decreases. So when we move in a group, like let's say group 2, which we are trying to do, when we move down, what happens is the metallic character increases down the group, the electropositive character increases down the group. So when metallic character or electropositive character will increase, definitely acidic character will decrease. Okay, so if you try to see, the acidic nature of oxides of alkaline earth metal decrease from beryllium to radium, as electropositive character increases from beryllium to radium. Okay, so when you talk about the most acidic, so the most acidic will be the one which is the least metallic, least electropositive. So if you try to see which is the least electropositive, it will be that element which is on the top of the group, that is beryllium. So it will be the beryllium oxide, BeO. Okay, so let us move into the next. So that is what we have discussed. Okay, so let us move into the next question. Among CaH2, BeH2 and BaH2, again we have group 2 element, and they have given us the hydride of group 2. The order of ionic character, now they are asking about ionic character, is, so they have given the 4 orders. Now let us try to see how the ionic character varies. Since ionization enthalpy of alkaline earth metal decrease down the group, that happens for most of the group, that whenever we move down the group, as the size increases, isn't it? When the size will increase, when the screening effect will be more as we move down the group, then definitely what will happen is the ionization enthalpy will decrease. That means the tendency to give electron will be more as you go down the group. That is what we have discussed in our previous question also, that as we move down the group, the tendency to give electron will become more. The tendency to form cation increases. That's what. When the system can give electron easily because the ionization enthalpy is decreasing, then the formation of cation increases, and hence ionic character of the hydrides increases. Obviously, when the formation or the tendency to form ionic or the cation becomes more, obviously the ionic character of the hydrides will increase as we move down the group. Okay, so the correct option will be BeH2 will be the least ionic, then CaH2 and BaH2, which is down the group. So as you move down the group, it becomes more ionic. Then let us go for our next question. Which one of the following condition will favor maximum formation of the product in the reaction? So they have given a reaction, and what they have asked is, they have given us certain conditions, and which condition will favor the maximum formation of product. Now this is a very common question, okay, or a very common topic which you encounter in most of the preparations. Like if you have already passed class 12, then what you know as Haber's process, okay, where you actually do such kind of favorable conditions. Okay, there are many other preparations where we use this, and the principle which we follow is nothing but the Le Chatelier's principle. So basically this is the application of Le Chatelier's principle. Now there are certain points which I'll be discussing. Please note it down. Okay, so remember that if you try to see, if you get such type of question, you always have to see that what is happening in the question and what is given in the question. Like in this particular question, what is given is delta HR, that is the enthalpy of the reaction, is given as negative minus X. We don't care about X. What we care is about the sign, negative. When they give negative, when delta H is negative, what we mean that it is exothermic reaction. And always remember that an exothermic reaction will always be favored under low temperature. Okay, since the forward reaction is exothermic, so definitely this reaction will be favored at low temperature. So if it is at low temperature, then either option 2 is correct or option 3 is correct. Now the question is whether low pressure or high pressure. Now again, a very important point. If you try to see the number of moles which are reacting, you have one number of moles of A2 and one number of moles of B2. One number of moles of A2 and one number of moles of B2. Total 2 number of moles is reacting to give you one number of moles of X2. So whenever the number of moles decreases, okay, always remember that whenever the number of moles decreases, then you need to apply high pressure. Whenever the number of moles increases, you need to apply low pressure. So in this case, the number of moles is decreasing. So it will be high pressure. Okay, so it will be option 3. Simple. Okay, please remember this 2 point. This type of questions will be very easy. So that is what actually is Le Chatelier's principle. So if you want to know more about this particular conditions of this particular principle, do actually read the Le Chatelier's principle, that is from the chapter equilibrium, chemical equilibrium. Let us move into the next question. In the structure of ClF3, the number of lone pairs of electron on the central atom Cl is. Now, so they have asked about the lone pair 4, 2, 1 and 3. So again, to find the lone pair or to find the structure first, what you need to know is VSEPR theory. I have discussed many other structures in my previous video. Okay, so in a very similar way, you need to know VSEPR theory, which is very, very important. If you know VSEPR theory, many of the problems you can easily do. Okay, because most of the structures which you get, or whenever once you actually learn VSEPR theory, then the structure, the question which comes based on structure or lone pairs or bond pairs becomes very easy to tackle. Okay, so if based on VSEPR theory, if I draw the structure of ClF3, that is what I get. It is trigonal bipyramidal with two lone pairs on the equatorial positions. Okay, now it is actually, the geometry is trigonal bipyramidal, the shape what we call as T-shaped molecule, and if you try to see over there, there will be two lone pairs present in Cl. So the answer is 2. Coming for the next question, or the last question, the correct order of N compounds, that means nitrogen compounds, in its decreasing order of oxidation state is, so they have given the elements, sorry, the compounds of nitrogen. What you need to find out is in which of them is in the decreasing order of their oxidation state. In very simple word, you need to find the oxidation state. I hope most of you know that, but for those of for some of you who don't know how to calculate oxidation state, so I have shown for HNO3, you can clearly see 1 plus X. X is for nitrogen, which I don't know. 1 is for hydrogen, plus 1, plus 3 into minus 2. Oxygen always have oxidation state of minus 2, except in few cases where it does not have minus 2, will be equal to 0. X will be equal to plus 5. In NH4Cl, again in the very same way, if you calculate X, you will get as minus 3. In NO nitric oxide, if you try to calculate, you will get plus 2. And in nitrogen, N2, since it is elemental state, so it will be 0. So if you try to keep it in the order, then it will be plus 5 first for HNO3, then NO plus 2, then comes N2 0, and finally the least is minus 3, which is for NH4Cl. So that is the correct order. So that is how you need to tackle various questions in this way. Okay, so do subscribe for this channel for explanation on various topic in chemistry. Thank you everyone.